Okay, so integrals of the form like this. Let's say you have sine power m of x times cosine power n of x. Okay, so the product of two sine and cos, each one to its power. Okay, so this is what I'm interested in. There are three cases, okay, when you have an integral like this. So first case is when m is odd. Okay, so basically the exponent, the power of the sine is an unknown. Okay, so this is very easy to do. Okay, you can understand with an example. Let's see the integral of sine cubed x times cos, I don't know, of 10 power 10 of x dx. Okay, so here's a case. Okay, so sine power something, cos power something, but the sine is to an exponent that's odd. Okay, so what do we do here? You're just gonna take one sine and you're gonna save it for your substitution. You're gonna understand what I'm saying? So it becomes sine squared x times cos 10x times and then sine x dx. Okay, so I did not change anything, as you see. Okay, and then I'm going to rewrite sine squared. You all know that this is 1 minus cos squared. Okay, and now I'm going to do a substitution. U is equal to cos of x, which means that du is negative sine x dx. Okay, so sine x dx here is negative. The integral of 1 minus u squared, cos squared, u squared, times cos 10, so u10, times sine x dx, which is negative d. Okay, this is the integral of u10 minus u12 minus, I can put in front here, u. Okay, and if I integrate this, it's negative u11 over 11 plus u13 over 13 plus, okay, and then I replace the u by what was it, cos, and I'm done. So I have cos 13 x over 13 minus cos 11x over 11 plus c, and this is my answer.
Wait, so where did the U12 come from?
It's u10 times u2. U10
Okay.
times u2, like distributed here.
Okay.
This is the first case.
Sir,
Yeah.
Where did you get the sine squared x equals 1 minus cos squared x? Just above the substitution.
Sorry?
Just above the substitution.
Where did I get this? Because there's an identity that tells you that sine squared x plus cos squared x is equal to 1. You know this one?
Yep.
That's it. So if you isolate sine squared, you'll get 1 minus cos squared.
Okay, thank you.
Okay. Okay, so this is the first case. Second case is, of course, when the n is odd. Now imagine the exponent of the cosine is odd. Okay, so n is odd. So let's say the integral of, so let's do sine 4 of x times cos, let's do 5 of x dx. Okay, so same idea, except, of course, I will take out a cosine. Okay, instead here I took out a sine with the dx. I'm going to save a cosine now with the dx. So integral sine 4x cos 4x times cos x dx. Equals, okay, so this is cos squared, so it's sine 4x times, so cos squared times cos x dx, and cos squared is 1 minus sine squared. You okay with this? And then just like what I did here, I do here, except now u will be sine. And du is cosine x dx. So I have the integral of u4 times, this is 1 minus u squared times cos x dx, which is du. And that's a very easy integral again. So let's do it. Integral of, so this will be u4 minus 2u6 and plus u8. Okay, I just multiplied everything out. Gives me u5 over 5, still, minus 2u7 over 7, and plus u9 over 9 plus. Okay, and then I replace the u back by sine x, and I'm done. Sine 5x over 5 minus 2 sine 7x over 7 plus sine 9x over 9 plus c. That's it. Okay, so anytime the m is odd, you will save a sine x dx for your du. Anytime the n is odd, you will save a cos x dx for your du. What if both of them are odd? Well, you choose whichever you want. You're free. Okay, both will lead us. It will lead you to the correct answer.
Sir,
Yep,
what about if none of them are odd? What do you
very
do?
good. That's my space that I have here for my last case. Okay,
Okay.
it's a good question. So case 3. What if m and n are even? You're right. Okay. So for this, there are two identities that you need to know, which are not very popular, but you should have learned them in high school. Okay, but most of you don't, unfortunately. Okay, and this is these ones, that sine squared of x is 1 minus cos of 2x over 2. And the other one is that the cos squared of x is 1 plus cos of 2x over 2. Okay, so these are two identities that we're going to use here. Okay, so let's do an example. And we're going to finish with this today. So the simplest one, sine squared x times cos squared x dx. Okay, so as you see, they're both even. So now it's useless to separate a cos or a sine. It won't help me. It won't work. Sine squared, so I use this identity, 1 minus cos 2x over 2. And then cos squared x, I use this identity, 1 plus cos 2x squared. Dx. I could pull out a quarter. And 1 minus cos times 1 plus cos is 1 minus cos squared of 2x dx. And 1 minus cos squared is, we know that 1 minus cos squared is sine squared. So I have here 1/4 integral of sine squared of 2x dx. I hope I can fit everything in the little space I have here, which is 1/4 integral of, and again, sine squared is 1 minus cos of 2 times the angle over 2. So I'm going to use again 1 minus cos of 2 times the angle, so 4x over 2 dx. Let's pull out the 2, 1 over 8, and have the integral of 1 minus cos of 4x dx. And that's easy. Okay, I get, you still see yes, so 1 over 8. The integral of 1 is just x, minus the integral of cos is sine 4x. And if you would do a substitution, u equals 4x, you will see that you will get du over 4, so over 4 plus. Okay, so this little step, I'm doing it mentally, but you should here do a little u sub. U equals 4x, du is 4dx. That's what happens here. Yeah, unless you can still see, I think the dx went away. So fix it. There we go. And that's my answer.